Hey guys, normally I do this in the lab, but it's the weekend, so I'm compromising a little bit and I'm working at home for you all. Alright, so today we are going to talk about enzymes just a little bit. Enzymes, if you recall, are responsible for maintaining chemical reactions. Okay, they are catalysts, in other words. The enzyme we're going to be kind of playing around with a little bit here is something called catalase. Okay, and if you recall, enzymes all end in the suffix ase, so catalase is no exception to that. Some of you might have heard of something called elephant toothpaste, so that's what we're going to be working with today. We'll have a little fun and I'll make some elephant toothpaste and we'll kind of go from there. All right, so again, I'm out in the lab, so I do not have beakers. Instead, I have my awesome Hello Kitty cup and my cup of love. All right, I have daughters, so deal with it. Okay. The organism we will be working with is baker's yeast. All right. Yeast is a fungus, so it's a living organism with enzymes. And in this case, like I said, the enzyme is called catalase. And in my cup of love, I have water. So we are going to just pour some of the yeast into the water. Let's see if I got it on film. Let's do another one. You know, more yeast is a good thing, right? So there, now we have 2 little packages of baker's yeast, and we're gonna make a nice little solution. I'll kind of stir it up a little bit, all right? So there we have yeast, which is in a nice little solution. I could even stir it up more just for chucks and giggles. All right. Here in my Hello Kitty cup, we're going to be pouring the hydrogen peroxide. Hydrogen peroxide chemically is similar to water, except instead of being H2O, it is H2O2. And I'm not being all that scientific in terms of measurements. I'm just going to pour, you know, about half a cup in there and we'll see what happens. In the video I'll show you later on with a fella named Mr. Anderson, he gets a little creative. It's actually pretty awesome. He puts little pieces of paper. They're called paper chads. It's like something you get from like hole punching, right? To be a little bit more consistent with elephant toothpaste, instead of putting pieces of paper, I'll just put dye. I'll also put some soap in there. Regular old, you know, kitchen sink kind of materials here. And you'll see why in a second. I think when you have soap, it will enable us to see the bubbles that are going to come out pretty easily, okay? So I've got dye, I've got some soap, I'm already making a mess. So let's see what happens. Just watch and learn. It's almost like a little volcano. It just keeps coming, keeps coming, keeps coming, keeps coming. And keep in mind, I had a small little cup. You know, if it was a bigger beaker, you get to see it come over the top and whatnot, and that's always kind of cool. But it's still, you see it's still slowly oozing out of there, okay? It almost has the texture of shaving cream. It's also very warm to the touch. And that's a whole other discussion topic when we get into exothermic reactions, but that's for another day, I suppose. Okay, so let's kind of wrap up what we saw here. We have bubbles that came out. What do you think would be in those bubbles? Well, that's oxygen. Oxygen bubbles were liberated from this catalysis type reaction. Okay, oxygen bubbles were liberated. Okay, and what caused this reaction to occur? The enzyme. The enzyme was called catalase. And where was the catalase? You got it, man. Straight from our yeast, because yeast is a living organism and living organisms have enzymes. What do enzymes end in? Ace. Man, we are on fire. We are just rocking and rolling. Let's use some more vocab terms, okay? The bubbles that were being released, that's my dependent variable, correct, right? And what is affecting the or what's going to cause these bubbles to be released? The enzyme, okay, the yeast, right? So this package right here, this is my independent variable, and the oxygen bubbles are dependent upon that amount of yeast. So I could add more yeast and more oxygen would be liberated, okay? The last little vocab term I'll just kind of throw out there quickly is enzymes have to react somewhere, right? Just like if I want to enter a building, I have a key and the key enters the lock. And we'll talk more about this down the road. But these enzymes have substrates. So the enzyme, in this case the catalase in my yeast, has the substrate, the key, if you will, to enter that oxygen, to enter the hydrogen peroxide rather, to release or liberate the oxygen. And I'm talking way too much. I'm starting to ramble, so I think we're good, boys. I'll show you a couple of the clips and we'll go from there. Be good.